Hi everyone, welcome to this lecture. So in this lecture, we will learn about a very important process known as exponentially weighted average. So this is the process which is adopted by all the optimizer in order to make the weight updating process smooth. So let's see how this process works and how it smooth the process of weight updation. Now look at this figure. Now we have a green signal here. The green signal consists of many data points which are vibrating or fluctuation. Now we can see that the vibration in the vertical direction or the movement in the vertical direction in the green signal is more as compared to the horizontal direction. So what will happen due to this large vertical vibration? So due to this large vertical vibration, this green signal will move slowly from left to right and it take a very large time in order to reach to the destination. So in order to solve this problem, in order to remove this vertical fluctuation from this green signal, we need to take the weighted average, or we need to take exponentially weighted average of the data point present in this signal. Now, how to smooth this signal? So basically, we have to take the average value of the data points present in this signal. Okay, if we take the beta equals to 0.5, it means we are averaging over 2 points. If we take beta equals to 0.9, we are averaging over 10 points. And if we take beta equals to 0.98, we are averaging over 50 points. So beta is a parameter which controls the moving average process. If beta is 0.5, if you select the beta equals to 0.5, it means you are taking average over 2 points. So this is the equation of selecting the point. Here, if you put beta equals to 0.5, then you will get 2 data points. If you put beta equals to 0.9 here, you will get 10 data points. And if you put beta equals to 0.98, you will get 50 data points. So beta is the parameter which controls the moving average, and it also controls how much smoothing you need. If you put the value of beta large, it means you are taking average of more points or large point, you will get more smoothing. Now look at the three smooth version of this green signal. The first version is the red signal. If we see, red signal is the averaging over 2 points for which beta is equals to 0.5. So we can see that here we have smoothened a green signal, but still the fluctuation is present in the red signal. If we want to smooth it more, we have to increase the number of data points over which we are going to take the average. For this, we have selected beta is equals to 0.9, which represent the average of a 10 points. When we take the average of 10 points, we can see this yellow signal. Now, if you see this yellow signal, it is more smooth. It is more towards the horizontal direction rather than the vertical direction as compared to green or a red signal. So the best version till now is the yellow signal, where we are taking the average over the 10 points. Now, if we want to further smooth the signal, we have to increase the data points over which we are going to take the average. So if I put beta equals to 0.98, it means I am going to take the average over 50 points. Now you can see the purple signal here. Now this purple signal is the best signal. It has almost no observable fluctuation in the vertical direction, and its all movement is towards the horizontal direction. So if you keep on increasing the value of a data points in the averaging process, you will see more smoothing. So this is the process known as exponentially weighted average process, and beta is its important parameter which controls the moving average, and the value of beta decide how much points you are going to take in order to perform the averaging or the smoothing of the signal. So what happens when we have an optimizer? The purpose of optimizer is to update the weight. So during the update of the weight, we have to reduce the loss function. So basically, we have to reach the minimum value of the loss function. So what optimizer do? When they try to reach to the lowest or the minimum value of the loss function, they start fluctuating like a green signal, and they take a long in order to reach the minimum value. So in order to improve their working, in order to improve the smooth transition towards the lowest value of a loss function, we added the exponential weighted average with the optimizer so that they can move faster towards their goal. So I hope you understood the concept or the importance of exponentially weighted average mechanism. Thanks to listening. Thanks for listening this lecture, and I will see you in the next lecture.